Hi everyone, welcome to the regression analysis lecture. This is one of the subjects at the Statistical Science Study Program, Department of Mathematics, University of Indonesia. For this session, we still be discussing about model building, and then previously we've discussed about model building for the quantitative variables. That is, if we have one predictor, if we have two predictors, and if we have more than two predictors. Okay, so for this session, now we will more focus on model building for qualitative variables, that is just one predictor. Okay, so in this case, we will consider how to put in, that for just one predictor, usually we have the template model is like this, expected of y equals beta naught plus beta 1 x1. But then in the case that x1 here is a qualitative variable, how do we really write the model, okay, in the context of the problem? What if x1 is a qualitative variable with two levels, with three or more levels, and then about the baseline, if we want to change the baseline, how, and the consequence of changing the baseline, we will also consider that thing. Okay, so we will just proceed directly to the our simulation to illustrate how we work with the model building. Okay, so here I already what is it I already developed some codings for the for our purpose of model building with qualitative variables. So here let's just have a look at one qualitative variable with two levels. Okay, so here I created a sample of size 100, and then that data consists of categorical. In here I choose gender, male and female, so two levels of the category, and then we have some measurement on that on each of the observation. Okay, so if we want to have a look at the data, it looks like this. Okay, so we have 100 data points consisting of the explanatory is the gender, and the response is some kind of measurement denoted by y. So then in this case, how do we write our model? Then we have that like in the standard form is that um, we have expected of y equals again still beta naught plus beta 1 x1. Okay, but now how to deal with that x and that kind of things is something like um, what we are going to do now. That is, for example, something like this, male and female. Okay, so probably if you want to do like I can just write my model something like this. Okay, so I will just write this is as a template, and then some changes that we will do in here, down here. Okay, so my model will be something like that, with the x1 equals to 1, for example, if that is, let's say, female, and then 0 otherwise. So in this case, actually your model, actually you have two models. That is a model for female, and then you also have model for males. Okay, model for females, and then you have model for males. What is the model for females here? Okay, so for female you have one. If it is female, then your model should be just have something like this. Let's see, so here we have uh, for females, x1 equals 1, so your model is just like this. Okay, and then for males, actually your model is just again taking from the template here. If one is female, male is included in this otherwise, which means 0. So your model should be just something like this. Okay, so that's how we break down our model for categorical variable. And then, so we can just do the interpretation of beta 1 here, or beta naught. So then we have the interpretation here is that beta naught in this case is that the average or the expected value, okay, or just the average of value of y for males. And beta 1, what do you think that beta 1? Beta naught plus beta 1 is the average of y for females, but beta 1 itself is that the difference probably higher or lower, higher or lower depends on the sign, whether it is positive or negative. The difference in the average of y for females compared to males. Okay, so if beta 1 is positive, then females has higher y value. Okay, so in this case, let's say, let's have a look at what is the data looks like. Okay, we have something like this. Okay, so female has lower value of y on average than males. So for this model, I will expect that beta 1 should be negative. Okay, if we have this kind of recording. Okay, in this case, when I have the model definition of x1 is like this, we say that the baseline or the reference is that the level or the male. Okay, that's our baseline. So in this case, according to this, we will expect that beta 1 should be negative. Now let's have a look at the result. Okay, so if we do the regression here, okay, we'll just do it again. Okay, so here, okay, so in this case, it just put male for the beta 1 or for x1, so it should be different with us here. So then we have here x1 is 1 for male, 0 otherwise. In this case, the baseline is female. And then so model for males. So this one is model for males, this one is model for females, okay, because now female is the baseline. That's because it gives us the output like this. And then so the interpretation is that beta naught is the average for females, and then beta 1 is the difference in the average of y for males compared to with females. So in this case, we have the result is that for males is we have 18.08 or just 09 plus 9.11. Okay, and then for female is just 18.08. Okay, because here is times 1 for male times 0 for females. Okay, so in this case, we can say that the average value of y for females is 18.08, and then male is 9.11 points higher than female or higher than the base level. Okay, I think the result is in line. Here we have that female is lower. Okay, so that's for two level of categorical variable. What if we have three levels? Okay, let's see if we have three levels. like this. Okay, so in this case, three levels. Here I generated also some hypothetical data. In here, let's see. Uh, okay, so this is our data. Is in here. We have x and y, and now we have categorical variable for the x with three levels. In here, let's say color, red, orange, and blue, and then we have some measurement, depends on the color for the first observation up to 150 observation. Actually, in here we can see blue has the lowest average on y, and then orange in the middle, and red is the highest. So then if we have to write the model for the qualitative with three levels here, so we can just have again something like this, but now I change it that uh, okay, I just copy it, and then here we have that the model is that because we have three levels, it means that we have now in here beta 1 x1 plus beta 2 x2. Or you can just say, actually we just have one variable, right? Okay, blue, orange, and red. So you can just put whatever you want to, for example, x1b because I want it to be blue, and then x1o because I want it to be orange. Okay, so in here, what the definition of x1b is 1 if it is blue, and then 0 otherwise. And then we have another one for the second level, that is we have x1o is that 1 if it is orange and 0 otherwise. Okay, so what about the red color? Okay, for the red color we don't need to define anything because that's the baseline. So if x1b is 0, x1o is 0, it means that it is red. Okay, so that's why uh, for k level of categorical variable, we just need to have k minus 1 dummy variable. Okay, so here I write if we have k level, then we need to have k minus 1 dummy variables. Okay, what do we mean by dummy variable is this indicator like s1b and x1o here. Okay, you can just interchange whether you want it. I mean that if you want to be x1, this one is to be red and blue, that's fine. That's okay. It means that the baseline is the orange. Okay, and the interpretation will be the same. It's just that what is it? Um, it's just that the estimation of beta might be different, but we can just prove that the relative comparison is still the same. Okay, so then in here we have that actually model for blue here, for blue color, then we have beta naught plus beta 1 times 1. So I just copy paste this thing. Okay, this is, so here we have model for blue. See here for blue we have x1 blue, x1b is 1, so beta 1 times 1, and then x1o will be 0 for blue. Okay, and then model for orange is that we have, again just copy paste again this thing, and then for orange x1b would be 0, so here everything goes to 0, and then here x1 orange, x1o would be 1, so 1 times beta 2 we have beta 2. And then the last one, because we have three levels, which it means that we have three models. And the last one is model for red color, which is the baseline. Okay, so for our baseline, oopsie. So for the baseline here, remember, still we have this model. Okay, so for the baseline here, okay, so for the baseline, red color, our model is still the same, but then, okay, for red color, x1b is 0, so this one disappears. x1o is also 0, so this one disappears, okay? So then from this one, actually we can see that the interpretation of beta naught, if with this kind of coding, okay, is that beta naught is the average in y value for red color, orange is beta 2 is that the comparison. For example, if it is orange color, then the value of y is beta 2 higher than red if beta 2 is positive. If it is negative, then orange is lower than red. And also here beta 1 is that the comparison of blue of the average in Y for blue color compared to the baseline, that is the red color. Okay, so then if we look at here, based on according to this result, okay, just based on this visualization, then we will expect that beta 1 should be negative, beta 2 should also be negative, and then beta 1 should be, what is it, greater than beta 2 in absolute value, because we can see here red is the highest, and then orange is the second highest, so it should be like less than beta naught, means beta 2 should be negative, and then blue is the lowest, so much less than beta naught, so beta 1 is also negative in a greater value, in an absolute value. Okay, now we try to run it. Let's see, what is it? Uh, okay, let's see if we run it. Okay, so in this case, they put that the first level are orange and red. So in this case, the baseline is the blue color. So I should change this with red. This is red, and so baseline is blue. So then, so model for red, this one is model for red, beta naught plus beta 1. Then the model for orange is the same, and this is for blue. Okay, and then from this output, we can see that the expected result is that we have expected value of y, or here we have that, yeah, we have that y cap actually is beta naught is 0.99 plus for red, so here plus 26. Okay, and then for what is it, for orange, here we have 0.99 plus 17.046 or 0.5, take two digits. And for blue, here we have the model is just the intercept. Okay, so that's what we have for red, orange, and blue. So we can say here that, okay, blue, the average is 0.99, orange is 17.05 higher or greater than the blue, and red is the highest at 26 higher than the blue, and it should be, yeah, it's just the same like the plot that we've got before. I think where's the plot? Okay, so here we have the red, 0.99, blue 0.99, and then orange 0.99 plus 17.05, and then red here 0.99 plus 26. Okay, now we can have a conclusion that for categorical explanatory variable, if you have kind of like one categorical variable with three levels, it means that actually you have three models. If you have categorical variable with two levels, that actually you have two models. So actually one model for one level. If you have categorical variable with k levels, then you will have k models, okay? And then each of the model is just constant and with the difference in each of the parameter represents the difference in the response y for each of the level. Okay, so that's for one categorical variable with two levels and three levels. Next, we will see that if we change the baseline, it doesn't change the result. Okay.